Okay. Mr. Wilson is a where's my annotation? 67-year-old male that's recently diagnosed with colon cancer. He's placed on drug A and drug B. The oncologist calls you and asks if drug B is primarily reabsorbed or secreted. So drug B, as we see here, the clearance is, total body clearance is 7.6. The FE is 0.75. The fraction unbound is 0.95, and it's a base. So, I'm gonna annotate, but I guess I can't figure out how to do that. All right. So, in order to figure out if it's is primarily reabsorbed or secreted, we're going to have to compare renal clearance to glomerular filtration clearance. So, found that out. Excellent. All right. So in order to figure out renal clearance, we're going to multiply total body clearance times the fraction excreted unchanged in the urine, which in this case is going to be 7.6 times, which is in liters per hour, times 0.75, which is going to give us our renal clearance. And we're going to compare that to our glomerular filtration clearance, which is GFR times the fraction unbound. So GFR, and we want to compare liters per hour to liters per hour. So what's GFR in liters per hour? Well, GFR I gave you is 125 milliliters per minute. And if we want to change that to liters per hour, we're going to say there's 60 minutes in 1 hour. So that's going to give us a milliliters per hour. And then there's 1,000 milliliters in 1 liter. So that works out to be 7.5 liters per hour. So we're going to have 7.5 liters per hour times our fraction unbound, which is 0.95 in this case. So our filtration clearance is 7.125 liters per hour. And our renal clearance is 5.7 liters per hour. So if we have 7.125 liters per hour coming into the glomerulus and only 5.7 going out in our renal clearance, what has to have happened? It had to be predominantly reabsorbed. So drug B is predominantly reabsorbed. So the drug is primarily reabsorbed, isn't it? So we know that this one is primarily reabsorbed. So what are our choices here? Well, we know drug is not primarily secreted. So drug B is, what the heck happened there? Oopsie, hang on, let me go back. I can't go back. Okay, so drug B would be primarily reabsorbed, which means the glomerular filtration has to be greater than the renal clearance. All right. How about this one? So this one is, Mr. Wilson comes to the pharmacy to pick up his prescriptions for drug A and drug B. During the counseling session, he shares that he has started taking cranberry extract for urinary tract health, and it's known to acidify the urine. So if it acidifies the urine, what's happening? We've decreased the pH of the urine, which is going to change the ionic character of the drug. So which interactions do you expect to occur? Okay, so we didn't figure this out, but I will show you how to do that. We know that drug B is reabsorbed. And what is going to affect reabsorption? Well, ionic character does, right? Because it's just got to be a passive reabsorption. So if we acidify the urine, and this is a weak base, bases put ionized over unionized, and if there's a decrease in the pH of the urine, it's going to favor the ionized species and stay in the tubule. So that's going to block reabsorption. So if you block reabsorption, more of it's staying in the urine. Therefore, the renal clearance is going to increase, and the CSS average is going to, I don't know why that's happening. Your CSS average is going to decrease, isn't it? So there would be a decrease in CSS average for drug A. Well, we haven't figured out drug A. This is about drug A. This is about drug B. There would be a decrease in CSS average for drug B. Yes, that's the answer, right? This one here. There would be an increase in CSS average for drug B. No, because more of it's being eliminated in the urine because it's changed to a more highly ionic species. Now, let me just talk quickly about drug A here. So drug A has, let's figure out what kind of drug that is, has a total body clearance of 12. Well, I think I have another question on that. So we're going to just stick with this for now. But I could tell you this is, if drug A is reabsorbed, it would be the same answer, wouldn't it? All right, now I'm gonna get rid of all those drawings, and then we're gonna move to the next question. Okay, that's correct answer. All right, now when glomerular filtration clearance is greater than the renal clearance, so what's coming into the nephron is greater than what's going out, you had to have reabsorption, right? So what's going to affect reabsorption? The ionic character? Yes, it is going to affect it. So this is a yes. The lipophilicity of the drug? Yes. If there's a change in lipid character, that will change the reabsorption. The concentration gradient? Yes, but not the KTS. What's the KTS? That's a concentration where half of your tubular secretion sites are full, and it really tells you about the affinity of tubular secretion, but we know this is really talking about a reabsorbed drug, isn't it? So the answers here are this one, and this one. The KTS would only affect a secreted drug, a primarily secreted drug. So that one is not correct. I must have the key wrong on the other one. All right. All right, wait, I gotta clear this. Okay. Well, which processes remove drug from the body? In other words, which of these processes add drug to the urine, to the nephron to be eliminated by the kidneys? Well, we know that drug comes in through the nephron, I'm sorry, through the glomerulus into the nephron, and then drug is also added to the nephron by active tubular secretion, right? And then drug is taken back out of the nephron into the blood. We think about the blood being here by passive tubular reabsorption, right? So which are going to remove drug from the body? Well, anything that's adding to this nephron. So that's glomerular filtration and tubular secretion. So active tubular secretion is one. Glomerular filtration is also true. Passive tubular reabsorption, no, that's bringing drug back into the body, and oxidation actually happens in the liver. So that's sort of a red herring, right? Okay, we got that one right too. Excellent. All right, this is back to drug A here. Is drug A primarily reabsorbed or secreted? All right, drug A, I have to get rid of this. So, okay, drug A has a total body clearance of 12.5 liters per hour. And in order to get renal clearance, we're going to multiply that times our FE, which is 0.5. So our renal clearance, I don't need a calculator for this one, 6.25 liters per hour, right? I wonder why it won't leave that there. And what about our glomerular filtration clearance? We have to compare them, don't we? So we're in liters per hour here. So we know GFR is 7.5 liters per hour. So GFR is 7.5 liters per hour. And we have to multiply that times the fraction unbound, which is 0.25 in this case. So it's going to be 1.875 liters per hour. So we have 1.875 liters per hour coming into the glomerulus and 6.25 going out in the urine. So we had to add drug, didn't we? So it's primarily secreted. So let's look at our answers. Drug A is reabsorbed, no. Drug, it's secreted, yes. Secreted, possibly. Not reabsorbed. So we're down to these two. So drug A is secreted since the glomerular filtration is less than renal clearance. Yes, this way drug is added. This is the answer, isn't it? If the glomerular filtration is greater, then the predominant process is reabsorption. So that one's not correct. Okay, good. So we're going to say that one's the answer, and we are right. Awesome. It says I got 60 right, but I got them all right. I must have the key wrong. Okay. Did I answer all the questions? Okay. I hope you found that to be helpful.